Hi, and welcome to this programming procedure video for the Stabilized Direction Control activity by MyBot. First thing you need to do is navigate to your Blockly interface. For information on how to do that, refer to your MyBot Basics document. From there, go into your Blockly menu and click Launch. Open a new scene, and then click on the Save icon to name your file. In this case, you want to name it your name underscore gyro, that's G-Y-R-O, direction underscore V01, and then click OK. The task for today is to write a program that can tell the robot to not only know when it's going off course, but autocorrect so that it continues traveling in a straight line. There are many different ways you could approach this, so feel free to adjust and explore and experiment with this code as you go through to find the code that's perfect for what you want to accomplish. Let's get started. Since we need to use the integrating gyro sensor, the first thing we want to do is set it to 0 its readings, which is to say that whatever direction our robot is pointing when we first start is what we want it to read as pointing at 0 degrees. That'll make everything else easier for us. So to do that, look for the Sensors menu, and then click on Integrating Gyro to get the options for that specific sensor. In this case, we just need the 0 Integrating Gyro command, so click on it and drag it into your scene. Then, drag it onto the bottom of your Fusion Start command. You'll notice it sort of pops into place. Now for the rest of our program, we need to set up something that will run continuously. And the way we do that is in the Loops menu. When you open that up, you have a few different options. So choose a repeat command, drop it onto the end of your existing code. Now let's set up the logic system that will control the robot's behavior during this loop. So of course, we're going to use the logic menu to do that. The top option is an if-do, and this command has a lot of flexibility with it because we can customize it to our needs. So click on it and bring it inside your repeat command. That way we can set it up so that all of these logical systems we set up will repeat. Now to customize this, click on the gear icon, and that'll open a settings box. We need to set up a program that essentially says, if this thing is true, do this. If this other thing is true, do something else instead. And finally, if neither of these two things are true, do a third action. Right now, it's only set up to do one action. If something is true, do this. So what we need to do is expand this and make it a little bit bigger. So we want to first add an else if to the bottom of our if command. And now when we click on that, we can drag it in the settings box onto the bottom of this. And when we do that, it's actually going to update our code itself. And then we finally need the if neither command. And to do that, we'll just add an else command to the bottom here. So in our settings box, we should now have something that says if, else. When you have that, click on the gear command to close the settings. This has set up our basic logic system. What we should do now, just to keep track of everything, is add some text commands so we know what each part of our logic is. Go into the text menu. And from there, grab a print command. Drop it into the first do section of your code. And we'll set the first part up to where we have the robot set to go right. So simply click on where it has ABC typed in automatically, and then type in go right. So with the print command selected, use your keyboard shortcuts to copy and paste. So Control-C and then Control-V. If you're on a Mac computer, use Command-C and Command-V to create a second copy of it. And on this one, we want our other option to be go left. So change the words in the second section to go left and drop your print command in the second of the do commands. Repeat that process and fill the else command with go straight. Once you've done that, you've set up a system of logic, and you now know what each section of logic is going to do. So let's start actually programming in what we want our robot to do for each of these sections. Go straight is the most intuitive, so let's start with that one. So to do that, go into your motors commands and grab both a command for M0, your right motor speed, and one for M1, your left motor speed, and bring those into the else section of your logic. Then in the last section you have a value, and you can set your power level of your motors using that. Now that you have these, copy-paste each of them and fill in the other two sections, the if and the else if, so that they each have a motor command for their right motor and for their left motor. Now, of course, we don't want the power settings to be the same on all three, otherwise we're telling the robot to do the same thing no matter what sort of readings it's getting on its sensor. So, for the first if-do section, the one where you want it to go right, adjust your values in such a way that your robot will go right. Think about how you need to adjust the right and left wheels to make this happen. Do the same with the if-else command for making the robot go left. Next, we need to set up the logic that will tell the robot when to do each of these actions. I'm going to use a compound inequality to do so and replicate what we set up on the student handout. In order to do that, I need to go into the logic menu and grab the command here that has an AND. This will allow me to create the compound inequality. And when I bring it in, I'm going to drop it at the first if command. Next, we need to add a comparison block. Again, in the logic ones, look for the command that has the two blanks on either side of an equal sign, and bring that into the first of your blocks on your AND command. This will allow us to set the angles that will tell the robot when it is traveling left and therefore needs to go right. Click on the equal sign to open the drop-down menu and select the symbol to create the compound inequality that you want. Next, we need to add the elements that are being compared. In this case, we need to compare a sensor reading to a value. So we'll start with the sensors menu and go back into the integrating gyro. And in this case, we want the get integrating gyro heading command. And I'm going to bring that into the first half of my comparison block here. Now I want to compare it to a value. To get to a value, I need to use the math commands and grab the very top one there, which is simply a number. Type your desired value into this block to complete the first half of your compound inequality. So now that we have the first half set up, click on the entire comparison block and again use your copy and paste feature to create the second half of our compound inequality. Adjust both the symbol and the value to complete your equation. Again, you want to set this up so that it's all angles that tell the robot it's traveling to the left. That way, when it reads that, it will go right to self-correct. Once you have that set up, select your entire compound inequality and copy-paste it and drag it into the else if section of your command, and then make any changes necessary to adjust your code. Again, you want to make sure you're setting up the angles in such a way that it can know which direction it's traveling and then how to respond to it. So good job, that section was intense. But now that we have the logic set up, we're pretty much ready to go. We only need to add a few more things. And the first thing I'm going to add is a text command with another print value. And this time I'm going to add it to the end of my logic. And this time it's just going to print what the integrated gyro heading is. That way I can use it for troubleshooting and to make sure my code is doing what I want it to. Now the only thing left is to tell our program how often we want it to repeat this. So from the time menu, grab a wait command and set it to however often you think we should be checking on this. Congratulations, your code is now ready for testing. So click play and see what it does.